Let's check them out. How many? 4 of them. Please try not to go back into the tree. Although with skill, you can actually pluck out a question and answer in the tree itself, but it's a little bit tricky. Okay, so you have to really know what you're about. Okay, so that's what I'm saying. Try to master using the outcomes to get your answers that comes after the construction of the tree. For example, it says, find the probability that after the 2 selections, that Shana selected 2 mangoes. Was it Shana? Yes, Shana. The answer is somewhere there. Anybody? Was the probability of Shana selecting 2 mangoes? 0.297, a mango, then a mango. Copy and paste. The probability of a mango, then a mango, is actually 0.297. Was the probability of Shana selecting 2 apples? 0.198. Let's go back into the tree, specifically the outcome section, to see if we get that 0.198. 2 apples, here it is, there it is. An apple, then an apple. Okay. So let's copy this. There are different ways of doing that. I could have just copied this one there. This is the font. It's already on. It has the proper size. And here now I can just change this to a capital E. Apple, then an apple. And go back to the value. An apple, then an apple is 0.198. So to maintain the font, I will rather type 0.198. Okay. What about, okay, so what I can do, I can just copy this, paste this, delete that, delete that, delete this. Okay, look at 0 point there. Copy this and copy that. A mango followed by an apple. What did you get? Here it is, a mango followed by an apple. Okay, I'm not sure why this letter A seems to be a mango followed by an apple. Okay. 0.253. A mango followed by an apple. So this is why we say no. You can even call this sign followed by, because that's what you see when you read it. You can see then, you can see and, you can intersect. A mango intersect an apple. A mango and an apple. A mango then an apple. A mango followed by an apple. 0.253. At least one apple. What did you do? Anybody? How did you analyze the probability of selecting at least one apple? Right. So remember, plus now, what is saying now, or what is implying technically, plus is O. Okay, so he's adding this. And why? Because of the O he's using mentally. Because at least one apple could mean an apple or more. Okay, so all where apple happening is at least one apple. So at least one apple can happen this way, a mango then an apple. That's one way an apple can happen. Okay. Or there's another way a mango can happen. An apple can happen, sorry. An apple can happen that way. At least one apple, sorry, can happen that way. That is two apples, apple, then apple. Okay. Or at least one apple can happen that way. So there are three ways at least one apple can happen. Okay. So that's why I'm using or. So let's go over this. At least one apple can happen this way, mango, then apple. Mango, then apple, or mango followed by an apple. That's one way at least one apple can happen. Another way at least one apple can happen is that an apple followed by another apple. Okay. Apple, then apple. Or there's another way at least one apple can happen. An apple in the first selection, then a mango in the second selection. That's another way of saying it. An apple in the first selection, followed by a mango in the second selection. Okay. Now we're ready for the 0.8. Well, let me just copy this. Well, let me bring this up because I see ready to go in the next page. We have some more to add. Bring this up. Bring this up. Okay. Bring this up. Bring this up. So now, you're ready to calculate it. So now, here night. The symbol for O is plus. The symbol for O is plus, so that's why he added it. So the probability of a mango followed by an apple is 0.253. The probability of an apple in the first selection followed by an apple in the second selection is 0.198. And the probability of an apple in the first selection, then a mango in the second selection is 0.252. And he simply added those three values. And what did you get?